Unlike green roof where you have many complex design, here it's as simple as just to dig a hole and just spread it out. Put some sand layer or some kind of gravel layer, and then you spread it out through that systems. So this is the example it shows. Um, um, these are the roads. It doesn't look like it's permeable pavements because you can see the difference between the regular asphalt road versus the permeable or porous asphalt, but these are there. And just to example here, there is a rainfall. Picture is not very clear, but it's raining, but you don't see any overland flow because all the rainwater is being soaked inside. So again, here there are some examples on the parking structure or other places. Here is a basketball court. It's very difficult to distinguish between those unless you look closely the grain distributions. So different components are there. First thing is, you got to define the design is based on how much capacity it should be. So the performance goal is about how much rainfall it can capture. And so then you have to think of site details. For instance, if the site is very high slope, then it's very difficult to actually have infiltrations because more likely become runoff. So you got to have a design in a way that can capture it. So those something you have to think of. And second thing, you have to also think of contaminant hotspot. Sometimes you don't want to have contaminant because it doesn't remove pollutant. So that means if you have a location which has very highly polluted site, you may not want to have this kind of design there because that short circuit those pollutants to groundwater. So again, you got to think of those. If you have a pollutant hotspot, you will not have a design of permeable pavement there. Then the third constraint is about infiltrations. Because this design, it does it short circuit the surface flow to subsurface, but it has to go from surface too. For that to happen, you got to have enough storage and some infiltration capacity into ground, or somewhere of a conveyor system where water can be discharged from there to other places. The last one, or more important, something that we don't think is the intended use. If the permeable pavement is it's just for walking, then it doesn't have to have high loading capacity. But if it's a road where car will be parked, then it has high load capacity. So that means you have to design all those systems such a way that it doesn't destroy the permeable pavements. It should bear that load. So all those design factors you have to think of, and then at the end, you have to think of what design type, whether it's asphalt, what type of permeable pavement, all those types you have to think based on cost. Last one is maintenance. Maintenance cost is actually very high because these are systems which get clogged very quickly if you have lots of sediment. So if you are designing a permeable pavement in some location, you have to ensure that the upstream has these sediment control systems. You have a first strip, you have other things so that it prevent all the sediments from other side to get into this area. Because once it gets into this area and the maintenance is expensive, you don't want that to happen. So all that factor you have to think of. Now you have two different design. Here I show you two different. The reason is the difference is I'll let you choose that. Now, can you see what's the difference?
Filter course.
Yes.
And the present of another choker course for the filter course.
This is raised outlet and filter course. Those are the big difference. Okay, so this is 1, 2. So now question is, one of them is water quality treatments, another is storage. So the one which has no filter is obviously not quality because filter is the one where you can remove pollutants. So that's why if there is no filtration, that means all it's doing is storing the water. And then now question is why there is a raised outlet in the storage layer. Can you guess? This is same design as in biofiltration systems or bioretention system. What's the goal of raised outlet?
Is it to enable nitrification?
It enables more infiltration into ground because you create this head So there is a ponding water height. So because you have lots of water, that push water to much faster into ground. So that's why that allow high infiltrations. So having this raised outlet means greater groundwater recharge. Okay, and because the main goal is for storage, that's why you have this layer much bigger. You don't have an infiltration layer or filtration layer. But same, the only difference between the right and left, if you think in that considerations, your goal is to have a filter layer, and that filter layer can remove at least some pollutants. If you want to kill bacteria or pathogens so that there is no biofilm formed here, so that might happen, some decrease the porosity, you want to have a filter layer and have some kind of materials that is antibacterials, or it kills the pathogens. And there could be combination of any of them. You can have different depth of filter layer, you have more or difference in the storage layer, and you have also under drain raised outlet versus not raised outlet. Again, as you see, there are a lot of optional cases. This filter layer is optional, under drain is optional, raised outlet is optional, but everything else is not optional. Means you have to have pavement layer, you have to have choker course, which is basically interface between two different layers. That's something you need to have to ensure there is no mixing, and each layer are protected. So those are the things you got to have. So just to
Professor?
summarize what we learned about design, you have a permeable, you have a porous pavements, and then you have filter layer. And when you have a filter layer, you always have when you have two different layer, you have a choker layer in between, just so that both layers are separated and become stable. And you see, pay attention to the thickness. So the thickness depends on what's the main goal. If your filter course is much bigger, then it is because you want to remove pollutants. You're not necessarily want to store that water. Once you remove pollutant, you are actually using it for some purpose. So that's why normally when you have a filter layer which is very deep, you don't have a storage layer. You usually drain that water and collect it for certain use. But at the same time, if you don't have a bigger filter layer, you do have um, the the reservoir course, or um, the storage layer. And the difference between filter and reservoir layer is the size of the thickness or the size of the particles. In the reservoir course, the materials is gravel or bigger. In the filter course, you have sand layer, more like a sand, coarse sand. And so if you say what's the particle size, what's the biggest particle size, this is large. This is let me write it somewhere here. So this is large, small, this is medium. Okay. I don't know why my screen has already frozen. So let me start again, because whatever I wrote is not visible. Um, right. So what I wrote here is the filter layer has to be small particle size, um, and the storage layer has to be largest one, and the choker course has to be medium because it just become an interface between each other. And design step, like you see here, uh, as I said, as long as you have the bottom layer, which is the one which, so you dig the hole, entire hole like here, it's written here, um, and then you can create a geosynthetic membrane if you do not want to have water to get into groundwater. And that geotextile membrane will ensure that no water infiltration into ground. And you do that only the cases where you want to store that water and reuse it for irrigations. So you put that one there, and then you put the storage medium, which is this kind of washed aggregate. The reason you want to wash it so that it doesn't have very fine particles to clog it. And you pour that here, you see they're being poured. And then once you have the pour, then you spread it out, and then you, so this is all the things spread out, and then you, at the end, you added the actual porous pavements or porous asphalt. So these are all, it's a simple process, really not, that's why it's very cheap to install when you have just a pouring structure. But if you, once you have something like interlock rock concrete, those are expensive because there are also machine which does that, but still, people have to check. There is more manpower there. So that's why the installation costs for those are expensive. So that's the design, and the maintenance. Again, you got to have maintenance because the sediments is the biggest factor which can make the system fail. So we have this, just to show here. These are the location where these things clog. So here it can clog. If it clog, then you have to spray water and fix it. And this is just an example, so that in the upstream, if there is any construction, these sediments will be all being released into the runoff. And then if it is deposited here, this will be all become clogged. And so once that happen, as you see here, you can see in this location, there has to be a big hole, but you see this is almost, that hole is missing. The reason is it becomes already very clogged. And same thing here, these systems have so many other things that here, those could clog, so you wanted to remove them. And here you don't even see the patterns because all the sediments are already deposited. So that's why you got to clean it by spraying water or high wind. Not wind, it's a carbon dioxide actually. Sometimes they do, dry ice. They spray dry ice into that to clean up the entire things. So how often you want to maintain? These are the maintenance regime. You have maintenance like 2 to 4 times a year, at least some kind of sweeping to prevent buildup of sediments. And if you, there are other things like you do is sometimes plants, if they grow there, if that's not required, then you don't have to, you have to remove the weeds, because that weeds will, the root will grow, then will crack, or they will not help the integrity. Most importantly, what weed does it has plants, and it created plant biomass that will deposit into the zones, and their biofilm will grow. So a lot of times people don't want plants, so you have to remove them whenever having possible by adding the weed control. And more importantly, you do at least a long, heavy maintenance at least once in a year to remove any kind of buildup of dust by using water jet or a dry ice jet. So this is just to show that what kind of preventive measure they have. For concrete grid pavements, you use mechanical, so that's why you are just brushing the one, and the other one you just air. You just high pressure air, you just blow in on it, and then or you use vacuum to remove all kind of sediments that trap there. So that's all for the permeable pavement. So next one will be